Hello there. Today, we get to do one of those types of videos that's something I've wanted to try for a while. And this was especially something that was a fire lit under me about 2 years ago when I got to go visit David, and I did a video about the IBM RT he has. But I also saw one of these while I was there. Not one of this exact model, but the general type of thing. This is a CAD Digitizer, and we'll take it out of the box and look at it in a moment. This is just kind of a difficult video to introduce and discuss because there are a lot of things that have to work right to demonstrate this, because we need the hardware, but we also need some software. So this is AutoCAD LT97, and I do know this is functional. I think it's all complete, and by that I mostly mean I don't think it has any super weird activation requirements. I have installed and tested this on a different computer than the one we're going to use today, but I haven't tested that this and that will work together. So fingers crossed that we're actually going to make some progress here, because today I want to try setting up a CAD Digitizer with actual CAD software on my Windows 98 computer. First, though, let's get this open and talk about what this is, because there is something that I cannot demonstrate here, and that's what this package is, and it's really interesting here. So, this is a whole thing. This was kind of new, kind of not. We're clearly missing some stuff, but this is the big deal right here. Oh, yes. This is excellent. Now, this is nothing, though, without this piece as well. This is what makes this really fascinating. This is not just a mouse, even though it has the left and right buttons. This is a cursor on the tablet, and that is your pointer, and this all works together. Oh, this is great. So what's really cool here is that this red ring is not just for style. This ring is a coil of wire, and that is how this is the actual pointer location, because it doesn't track the mouse, it tracks this ring, which makes this highly accurate and see-through to know exactly where you are pointing. Now that distinction is kind of weird and cool, and the pointer is corded, so it's not fully wireless magnetic like modern Wacom type things are. Although interestingly, this did have an optional pen, and there was a different pointer that had fewer buttons on it. It's a weird ecosystem. Let me talk about the TriStar versus CalComp here, because this is where this is a little weird. Now, TriStar was a systems integrator, it seems, that sold a TriStar CAD computer that ran a 486, and it cost $8,200, which is just crazy. But one of the things it came with was this, the Digitab II. But what this actually is a CalComp Drawingboard II. Now, the CalComp Drawingboard II came out in 1991 and had a selection of different pointer devices. Again, this one that is a full 16-bit hexadecimal input is just one of the available options, though based on the accessories list that came with the Digitab II version here, it looks like that is the only one that it would have come with. However, it should have come with drivers as well, which I did not get, so that might be interesting. Anyway, back to the Drawingboard 2 aspect of it. The $8,200 that TriStar was asking was at least partially justified by the fact that this thing was probably $600, which is a little crazy. It is a 2400 DPI matte, though. That is ridiculously high resolution. That even competes with modern Wacom devices now. So this thing is really impressive and kind of cool. And this is why I've been wanting to try one of these. It's just a completely different, weird kind of device. And, well, I want to see how it goes. So like I mentioned, though, I don't have drivers. So what I'm hoping is that AutoCAD here is actually just going to know to directly interface to a CalComp Drawingboard II, but I don't know. There is one thing we can test at least before we try and get this connected to a computer, and then I'll show you why I have a hope that this might just work. But let me get this thing powered first. All right, on the back of the tablet, we have the connector where the pointer device plugs in. In this case, it'll be the 16-button mouse. I'm going to go ahead and just call it a mouse. It's not a mouse, but it'll make everything simpler. The mouse connector, the I/O connector, which is important because it also relates to the power connector. Now, this device will connect over RS-232 serial. Serial doesn't carry power, so this has an external power supply that is 12 volts DC, center negative, and you'll have to plug that in here, and then you can switch the CAD tablet on when you need to use it. It's a little weird. It can't just send something over the serial port to turn it on and off, but you know, I guess power switch works too. Now, with everything plugged in, I'm going to turn the tablet on and bring my mic up here for a moment with it. It has a speaker in it that beeps when you turn it on, which is cool and weird, but it also has a power LED, and that is a helpful indication that it's working, because the power LED doesn't just stay on, but when I move the cursor up above into the configuration area, it starts blinking. So that tells me not only does the device still power on, but it can actually sense where the tracking pad is. So it's looking like this thing's probably going to work. Which means we need software, and this is where this quick start sheet that came with the Digitab TriStar version comes in a little handy. First off, we can see the driver disk I don't have. Hopefully we don't need that. But on the back side, we have a list of compatible programs and how the digitizer is configured in those. Now, this being a Drawingboard II, that's actually predates the version of AutoCAD I'm going to use. I'm hoping that it just has it natively supported, but if not, I can apparently try and set it to ADI, whatever that is. But yeah, it looks like we're going to have a couple of options potentially, although I don't have anything else here other than AutoCAD. That shows CAD key being compatible, but I only have key CAD, so But I am still fairly confident this is going to work with this version of AutoCAD, which is AutoCAD LT 97. And this was released in 1997, shockingly, for the price of $480 originally, though the one I have here was priced at $429 at CompUSA, which is kind of cool to still have that sticker on there, but also just, wow, that's an expensive program. But the LT releases of AutoCAD were actually the scaled down versions of the full-on AutoCAD. And there was an article that I was reading about this before I started filming today, where the author was complimenting this for being only a $500 software package, unlike the $5,000 full AutoCAD software package. And pretty much the only thing this is missing is 3D, which really isn't all that useful in the long run, especially when you're trying to just work with a digitizer. So I'm not too concerned about that. I'm actually very fine with this. And this is a very big package that has a lot of stuff in it, but it has one very critical thing that's going to be super useful here. And no, it's not the over-inch thick manual. It's this. When I first got this package of AutoCAD, I had no idea what this was. But this is an inlay that goes under the clear sheet there for controlling AutoCAD directly from the digitizer with all of the tools just right there. Multi-monitor still weren't really common at this time, so having somewhere else to put all of your selectable menu options wasn't really an option. So this is kind of awesome because your GUI is just physically here in the world, and then you don't need to waste as much UI space on your monitor for it. So theoretically, your monitor could now be much more full screen, and that's kind of cool. So I really want to try this out. This is the correct size pad for it. This barely fits in there, but it does fit in there. I don't know how you calibrate it. I'm imagining there's something like you have to click these dots that are around this. I don't know, this is as far as I've gotten with this. So I think it's time to bring this over to a computer now and see how this works, because I'm fascinated by this and I want to know what it's gonna do. Okay, it is set up now. It unsurprisingly does not work out of the box. Windows won't detect something like a serial device without explicitly having drivers tell it to do so. So before we install AutoCAD there, I have one thing I want to try. I did find some GTCO drivers, which I think is the name of the company that CalComp is produced through. It's a weird relationship. I'm not fully sure I understand it, but I want to see if they will work on here. So humor me for one moment to see if we can get this working as a mouse at least. Okay, so these are actually a collection of files that I found when trying to research this thing. I think it mostly came from one website that I found that still had some stuff hosted for it. I think it was for a university in a country in Europe. I don't remember exactly. I did this a little while ago, but it wasn't easy to find anything for this sucker. So I'm really hoping I can make something work here. Theoretically, I should have been able to get DOS drivers for this thing because it was a 46 for the Digitab 2 computer that TriStar was including this with. And I have no idea where DOS drivers would be. Those totally must have had like inbuilt program support. So I'm kind of really hoping for the best here. Windows 98, COM1. Okay. Searching. I don't even know if the motherboard's configured correctly for serial. Holy moly, it found it! Yes! Oh! Okay, it didn't just make it work. So this is a 12 by 12 inch, is it? Oh, okay. So this might actually be a $500 model then, based on what I found in a PC Magazine article. Okay, grid button test. How does... Oh, it's reading data. Oh, this is cool. Oh, they don't work. Raised. Interesting. Oh, hello. What? Yeah! Grid error. Yeah, so if you move too fast, it doesn't like it. Oh, that's so cool. Oh, wow. Well, all right. It seems like, yeah, 1991. That's kind of cool to confirm that with the firmware on it, I guess. Wow. I don't see a way of using it as a mouse, but at least we know it works. I'm not sure what all I could do with this information now. I can't click anything else there. It hasn't had any other device type. So yeah, I think I'm right. And programs like AutoCAD should just seek this out rather than try and like run it through Device Manager with a driver or something. So yeah, we're definitely gonna have to install AutoCAD. So let's go ahead and give that a shot. I am very curious how this is gonna go. Now, this is a very complete copy here, as far as I know. So this includes the learning assistance, the actual program, that, I don't know. Man, there's a lot of stuff in here. Dear AutoCAD LT 97 customer, thank you for purchasing Autodesk product. I hope you'll be happy with the latest version of AutoCAD 97, LT 97. Please refer to Chapter 1 for installation instructions. Who would have guessed I had to read the manual to know how to do the stuff? Okay. And then the utterly, ridiculously enormous two-color manual. Oh, no, there are some color pages in there. Ooh, fancy. Those are like magazine pages, and the rest of them are the standard thinly. Oh, and a quick reference. Man, this is just the package that keeps on giving. I'm gonna put the actual disk in the computer now though and get that installed. All right, I'm gonna go ahead and put the clear thing under here. Now I find this whole window thing in particular kind of interesting. I'm wondering if they're expecting you to put something else under even that for like tracing, which is not going to be the easiest thing to do. Also, this has a very difficult time getting like all the way up there. I don't want to view the README. I just want to play CAD. AutoCAD LT 97. All right. Does this? Yeah, I'm not surprised. It doesn't immediately work. Okay. Now we have to figure out how to do stuff. Manual. I give up. Where is it? There's the giant book. I'm sure this won't take forever to read through at all. Configuring pointing device. Okay. WinTab drivers are not distributed with AutoCAD LT. The digitizer must work properly with Windows to work with AutoCAD LT. And it wants me to install WinTab drivers provided by the pad company. So, okay. 2 steps forward, 3 steps back. I have something that looks WinTabby here. And if not, I'm gonna have to see if I can find that. Ooh, 2005, that's not... Sure, we'll restart, why not? I like that it beeped there. And that's a no on it. Oh, yes! Oh! Oh, that's awesome! How does it work? Okay, it's absolute positioning. Dude! Here we go. Oh, that's awesome. Okay, the drivers I will put up on archive.org because yes! Okay, WinTab. Do I have to check? WinTab is like an option? Okay, close that. Could not initialize ADI driver. Oh, we're getting closer. Okay. Today is now the 2nd day I've been working on this, and I'm not 100% sure what all footage I'm going to use from yesterday because getting this working was an enormous nightmare, and I don't even have it working fully the correct way, at least according to the manual here, so I'm not exactly sure what is the problem, but let me just quickly go over what I've tried. I thought I could just figure this out on my own, but I forget AutoCAD kind of lives by the command line it's got down there, so realistically, you kind of have to look it up in the menu how to do things. It has a section at the beginning that tells you, like, oh, here's how you set up the tablet, but it turns out that first bit in the book is completely useless, and it tells you to just go to an appendix at the back of the book for setting it up. So I go through that, and it works you through how to use the tablet command in AutoCAD to go ahead and configure it, set up your fixed screen pointing area, which I'll get to in a moment, and then talks about some of the menu things on the inlay and yada yada, but this is wrong, or at least it doesn't work. So, technically, I have this working now. I can move within the fixed screen pointing area. I can go over here, I can pick a line, and I can draw a line straight through this, and it looks like it's working, but it isn't. Or at least it's not working the way I think it's supposed to. This is going to be good enough for us to use today, but I don't know. Let me show you exactly how I configure this. Now, to configure the tablet, we could go Tools, Tablet, Configure, but honestly, I've done this so much now, I'm just comfortable with the command line. So we're going to go with it this way. So we're going to run CFG. And now what we have to do are define the different sections of the overlay. So it's asking us the tablet menus, and we're going to define all 4. So I'm going to enter 4 there, although I could have just accepted the 4 that is the default value in the braces. And this is what I need to override. We're going to, yes, I'm going to align the tablet menu areas. Okay, so now we're actually going to configure this. So the first thing is it considers this clear section on the top a menu. Now, initially I thought that was for putting something underneath of there that you would want to digitize, and I now understand why that is considered a menu. And it's because there are different versions of this inlay. Some of them are for specific expansions, I guess you could call, add-ons for the AutoCAD. One I saw was for architectural use, and it had different features specific for architectural functions. So, and they're included there. So say you had an electronics one, you could pick a symbol for resistor and just drop it into your design document. That could actually make a lot of sense. So that is what this is for, and I suspect you could define this as a custom menu because AutoCAD's really complicated and really, really configurable. So I bet that's possible. But anyway, so what I did here is I just picked an L shape basically, and then I tabbed through that really quick, but I'll cover it on the second one. So this is the second menu area now. And what happens is after you pick the 3 corners, it asks you how many columns and rows there are. I mean, you could try and count these. This is like labeled A through Y on one axis and 0, 1, I guess, actually through 25 on the other. And if you really want to count that, you can try, or you can just accept its default values if you have the original inlay. And on that, I think that the CD itself actually has a DWG file that can be used to reprint this. So that would be kind of cool. Anyway, menu 3 is over here, so we'll do that really quick, accept those values, and we'll do menu 4, which is at the bottom. I've so far found these to be fairly lax. You don't have to be uber-duper precise on that because the buttons are somewhat big. This is where the configuration starts to fall apart. So it's saying, do you want to specify the fixed screen pointing area? And if we go to the book here, I will go to Chapter C, configuring a digitizing tablet. Okay. In response to the following prompt, do you want to specify the fixed screen pointing area? They say enter yes, and then they have you do this point to this point. And what that's supposed to do, according to here, is before you configured the tablet, the entire surface of this tablet is actually the fixed screen pointing area. At that point, the tablet pointer performs like a mouse. You can change the size of the fixed screen pointing area to specify a new size. So what this actually is it's saying that how the whole area is currently used to move the mouse, you should be able to do it within this little window to move the mouse cursor on the entire monitor surface. That has not worked for me once. And trying to fight the configuration for about 2 hours yesterday, I never got it working at all under any circumstances. So I'm actually just going to disregard that feature entirely. So I'm going to tell it, no, I don't want to respecify that because I can't get it working. Then it has another question here. Do you want to specify floating screen pointing area? Now, I won't bring it back up from the manual, but apparently what that is a different version of this that you can make bigger and like overlap some of the other menu options. So say you don't need like the whole bottom side, you could have it take up that. And then you can bind it to a key or a button on here and enable or disable that on the fly. But just enabling that at all makes the entire menu configuration not work for me for some reason. Again, this all sounds really weird and like it doesn't make sense, but I've done this a bunch of times and I don't know why this is what it has to be done. So I'm going to tell it, no, I don't want the floating area, even though I should be able to use it. So at this point, it's still functioning like a mouse. So that's not really what we have to do. Tablet on to actually enable the tablet functionality, but the instant we do that, it's now going to tell us that the tablet must be calibrated. Okay, so I'm cutting this in from the future. Minor addendum, the fixed screen positioning area does actually matter, and it turns out that this was saving settings between restarts, and I didn't realize that, just in case I guess you do leave the inlay in there. The fixed screen pointing area has to be set, and then you define the calibrated positions within inside of it. Why doesn't it mention this in the manual? It just doesn't. Now, this is where this gets annoying and weird, and I don't really have a good example of this. But let's say you had an engineering drawing of something physical. So you had, like, say, a floor plan, all right? What you would do here is you would measure, say, 2 points on the floor plan that are hopefully have 2 axes of distance between them. And then you would tell it in your drawing diagram how big that is. And the idea isn't so much to calibrate the pad itself, but it is to calibrate on here how much distance there is, because the files that you create on here are aligned to real world units. That is how this is meant to work. So if you had your architectural drawings where it was 5 feet per inch, you would set this to English measurements, and then you could set, say, 60 as your number of points for the line that you drew. So I think at least that's how it's meant to work. But what I'm going to do here is I'm going to pick the bottom left of the fixed pointing area for this, and I'm going to set that to 0, 0. And then I'm going to pick the top right of this, and I'm going to set that to 400, 300. And the reason I'm doing that is because This is meant to be a representation of your computer monitor, and monitors were 4:3 aspect ratio. So I'm just setting this arbitrarily to 400 by 300 units. And I don't really care what the units are here right now. Again, this is not really functional. This setup doesn't work quite right. But as I input this and then finish out the menu, this will make it work. So that's what I'm going with and how I'm making this at least partially usable. But with that finally set up, I can demonstrate how this graphics digitizer will work with software like AutoCAD. So the most basic thing I think you could probably do is I could go over to here and I can put the cursor over the line button, and I'm just gonna pick that with the left button. It's not quite a mouse button, but it's kind of like that. Then I can go over to my calibrated screen digitizer area, and I'm just gonna pick 2 locations, and I'm gonna draw a line. Boom. We drew a line, and we can just keep going like this, and yeah. Now this might seem counterintuitive to use like a smaller section of this, but it's kind of the idea. There are different ways that you could utilize this device. So like one way is if you wanted to trace something, you could leave the inlay in here and then tape something to the top of this. And then you could trace over that. So there's a couple of different ways you could use this. So let's try and actually input something into this. So what I want to do is I'm going to pick something from this. So this is a National Semiconductor DC to DC converter document that I got, and it's from 1977. So this is kind of cool. And what I want to do is I want to try and digitize one of these circuits here. So let's say we were doing electrical engineering work and we wanted to actually import some of these into our schematic, maybe, you know, we could do that. So let's go ahead and try and do that with, say, this one for our regulator circuit here. This is also small enough that I can put it over this section, and then it'll work. So I'm going to use the edge of the box there to check my alignment, so hopefully it doesn't rotate. Another thing I'm going to do here is I'm actually going to use the line tool, and I'm going to pick a box around this. All right, we're going to go with that. And the only reason I'm doing that is because I can go to zoom extents, and what that does is it zooms just this area. So that's the area I will be working in. So we can see that. And it's kind of weird because now this one little tiny area is basically filling the entire drawing input area. This is why you would want the floating point area, because you could expand that out and have higher precision over a larger area. So let's say we wanted to copy that in and I didn't want to do it with something that's literally the size of my thumb. You could make a enlarged photocopy of it and then trace that in. You got to remember that this kind of hardware was mostly intended to be used before you could just easily capture bitmap graphics with like a scanner and then put it on here and then trace on that, or modify it and try and convert it directly into your CAD software. So this is meant more for manual processes like this, because there weren't many digitization options that weren't fully manual with literally a thing you hold. So do keep that in mind. But anyway, let's go ahead and give this a shot. So I'm going to have to try and remember to do this correctly because this gets a little weird here. So we're going to try to make a representation of this circuit on the computer now. So I will do that, and I'll fast forward through this. Okay, there it is. It's not perfect, but you can get the idea of how you could digitize something into a computer there. So if you're doing this more professionally, now what you could do is you could come in here, and we could select the different objects, like say this one. So what I could do is I could reposition the point there to something very precise. One thing it should be possible to snap. Ortho, polar, ISO, grid, snap, right there. So I'm gonna activate snap. All right. Now, what happens if I grab... Oh, the coordinates are really big. Really, really, really big. So I'm going to set it to 0.1. I had to dig through the manual so much to find this, by the way. Okay, yeah, there we go. So this is the kind of thing. So once you've digitized something like that, if I do something like this, all right, I can toggle snap. Perfect. Get the point. Retoggle snap. Bingo. Bring this, say, 4 in so it matches the other one. Toggle, snap back. Retoggle it. Oh, select. So yeah, you can go through and pretty easily clean stuff up. Go ahead and hide the grid so it can render quicker. And yeah, with that, then you could work through, clean up your schematic, and then have something that looks pretty good. So obviously this is not a fast process, but if you're doing, say, architectural drawings where these dimensions really matter, this could make a difference. Something like an electronic schematic, I mean, you'd probably use an EDA for it in the beginning, but something like this would allow you to import maybe an old paper schematic into a computer, and then you could work on it from there. But there is actually one other thing that I would like to try with this that deals with electronics. And in order to do this, I am going to clear out my configuration options here, unfortunately, because I want a bigger digitization area because I have an idea of something that might be kind of fun to try. One thing I think you could do with this is clone a PCB directly into a computer. So this is the PCB that I made to clone the CM153 to get my CM100 working. And I don't see any reason I can't just put it under here and, well, start cloning. Now, I'm going to do tablet, CFG, okay, number of menus desired, 0. I do want to respecify the fixed screen pointing area. I'm going to do the entire pad. Boom. Boom. Okay. Do I want to respecify the floating screen pointing area? Do I want to specify it? No. And now it is disabled. Okay. That should be it, but we do have to do tablet cal. All right. So what I'm going to do is I have traced the outer perimeter of the card to this paper. I can now take out my insert, and I'm going to put it in here. All right, I'm going to align the edges of it to the bottom left corner of the tablet. And now I can take this, I can mark the bottom left as 0, 0. And I will mark the upper right as 138.1, 97. And now we have our dimensionally accurate locations for the PCB. So theoretically, I should be able to pop this in here, keep that aligned like that. Now I can trace this, and this does actually work through the PCB, which is just kind of awesome. So first thing I'm going to do is I'm going to draw a box around the whole thing. That way I can zoom to the extents of it. So boom, 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 extents. There we are. So now the actual card will fit within here. So let's get a true board cutout. So bingo. All right. So there are the actual dimensions of our board on the monitor. So that's pretty sweet. From here, I could more easily manage zooming in and out to different regions as I work on it. So let's say we want to come down to just the card edge as I work on that. So the physical item is locked to the document's dimensions. This does not relate to the mouse positioning. So that's kind of sweet. It looks like it is slightly rotated compared to the document. That's fine. We'll not worry about that. For this, probably would be possible to fix that, but oh well. I think what I could do here is I could do, what are these, rectangles? rectangle. Okay, so I'm going to draw rectangles for the gold fingers. Okay. Now I'm going to mark out locations of chips on here with rectangles, and that'll let me get an idea where the pins would go. So just for a rough estimate, if I were doing this for real, this would be good for aligning the pads for this. So I could actually see doing this at least as a documentation layer. I'm doing everything on one layer because I'm trying to work fast and just demonstrate how the alignment works with the real physical object. And then from here, I could take the line drawing tool and I could actually start to add traces from the card edge to the chips. You could get a really quick map of like a whole card if you removed all the chips like this. I am going pretty roughly, but you could easily digitize something like this very quickly. This is kind of impressive and awesome. I didn't know that I would think this was this good. Wow. Like, I will just go ahead and quickly do all of the ground traces on here. So let me just do an extents view again. So, was it view, zoom, extents here. I'm just going to add all of the ground and power bars here really quick, which is not going to take much time at all. It's not super precise, but if you enabled a reasonable grid for this before starting, like if you had this, actually, yeah, if you had this set to like 25 mils, I'm actually a little curious here. I'm going to do this section over here, all right? 2.54 millimeters, all right? For the snap and the grid, 2.54, all right? And we'll enable the grid as well. Okay. I'll go back over to this. So boom, 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 boom. Oh my gosh, this is amazing. Boom, 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 boom. There we go. And they're now up above as well. So those are the pads for the chip. Okay. 0.635. I'm stupid. I'm working in metric, but I'm using imperial spacing. So I know I'm an idiot. But what I want to try here is putting traces from the card edge connectors, which are technically at 100 mil offsets. I want to try connecting these to those pads and see what happens. Okay. Oh, that's ugly. Wow, that did not work right. Some of them did. That trace is actually how that should look. So some of these get a little weird. Maybe if I'd started out by aligning everything else. I'm actually kind of interested in this. I'm half tempted to see if there's something else I can do this way. Because this is kind of interesting. Obviously, again, the modern way is to just scan the PCB and trace over it. That's on the computer, not physically on here. This is cool. All right, well, I think that mostly wraps it up here for the CalComp Drawingboard II, which I did eventually get working. It took a lot of fighting to get it to a point where I was happy with it, but I feel like I kind of now understand how it and AutoCAD interact with each other. I still don't understand why the fixed screen pointing area doesn't work, but part of that might be that I think these types of devices were mostly starting to fall out of favor by the time this kind of software was becoming popular for Windows. So the capability of that might not be that battle tested, especially with different software and drivers. So I don't know. It doesn't seem like that might be the way to go. But there is hope in the future because as I was trying to troubleshoot this, I got in touch with RetroCAD, who has a Twitter account and a YouTube channel that I would highly recommend. He's got some cool stuff on there. And they were able to archive driver disks for this that cover Windows 3.1 and DOS. So if I ever get my hands on a DOS copy of AutoCAD, or a different compatible CAD software with one of these, then I could try that on there where it might actually exceed a little more. Although overall, I'm actually very happy with how this worked, especially towards the end there. I think if I really put some time in with this and learned how to get it to do the snapping the way that I wanted and set up a project in advance rather than just kind of starting and going, I mean, usually you're putting in a little more thought when you start to work on a CAD project like this. So for having put in zero effort at all to lay that out, I'm actually kind of really impressed with how that turned out so far. So yeah, overall, I think this thing's pretty sweet. You probably wouldn't want to use it for anything outside of CAD. I can't think of much because in every other use case, a mouse is just better. I mean, even for drawing, maybe if you had the pen version for one of these, it might be nice for drawing, but there were dedicated drawing tablets and they're way cheaper to get and easier to set up. So I would probably just go that route. But anyway, that is it for now. If you guys enjoyed this video, I will definitely have more weird CAD hardware in the future. I have at least 2 other things I want to check out at some point. This video, I actually had planned to make like all 3 at once, but I realized I should just do each one at a time, and man, this thing kicked my butt. Yeah, really demonstrated they should each be their own. So anyway, if you liked this, you might want to subscribe to see those future CAD hardware videos at some point. If you want to help support the channel, then you can find me on Patreon. But for now, that's it, and I will see you next time.